Well, hello boys and girls. In today's video we are going to talk about this concept called the mole. First we're going to discuss what the heck a mole is, and it is not the mole that you find on your face or those cute little animals that burrow in the ground. It is this right here. We are going to talk about what a mole is used for, and we are going to talk about how you obtain a mole of something in an actual lab situation. So what is a mole? A mole is just a number that's equal to 6.022 times 10 to the 23rd. So 1 mole is this number. That's a really, really big number. In fact, this would be a mole if I expanded it out from scientific notation. It is 602 billion trillion, so it's a huge number. A mole is a counting number. Other counting numbers you may be familiar with are a dozen. So 1 dozen is equal to 12, or say a ream of paper, 1 ream is equal to 500. So these are both counting numbers as well, and so is the mole. So I can count things in groups or by counting numbers. So if I had a dozen donuts, that equals 12 donuts. If I had 2 dozen donuts, then I have a total of 24 donuts. And the same would be true with a mole. If I had 1 mole, I would have 6.022 times 10 to the 23rd donuts. And if I had 2 moles, I would have twice that number in donuts. That is a lot of donuts. You will sometimes hear a mole referred to as Avogadro's number, named after this dude. His name is Amedeo Avogadro. He's the guy that came up with this counting number. So he was the first person that proposed the idea that we should start counting items in this quantity as opposed to, say, a dozen or a ream. We count in this grouping of numbers. All right, so let's put this into a little bit of perspective. We know what a dozen of something would look like. How much would a mole of something look like? Well, if you had a mole of soda cans, it would cover the surface of the earth to a depth of 200 miles. If you had a mole of unpopped popcorn kernels, it would cover the United States 9 miles deep. If you had a mole of dollars, that would be enough to pay the national debt 30 trillion times. If you had a mole of sand grains, it would cover the United States 1 centimeter deep. If you had a mole of paper, you could stack it to the sun 1,000,000 times. And if you had a mole of grapefruit, it would roughly equal the volume of the earth. And if you had a mole of water molecules, you would have about 18 milliliters or 3.5 teaspoons of water. What? Well, what that means is that water molecules must be really, 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 really small. If you can have a mole, or 6.022 times 10 to the 23rd water molecules, and you could drink those in 1 drink. 1 drink of water is about a mole of water molecules. So that brings us to, what on earth would you use a mole for? What kinds of things would you count by moles? Well, certainly you wouldn't count things like donuts or soda cans or popcorn kernels or pieces of paper by moles, because that number is such a huge number. So what would you count moles or by moles? So a mole is used to count really small things, really, really small things. Things like atoms, molecules, or formula units. So let me show you a mole of a bunch of different things. So here I have a picture of a mole of a whole bunch of things. So in each of these containers is a mole of whatever it says it has. So this is a mole, or 6.022 times 10 to the 23rd mercury 2 oxide formula units. And this is a mole, or 6.022 times 10 to the 23rd sucrose molecules. Here we have a mole, or 6.022 times 10 to the 23rd sulfur atoms. Here is a mole of copper 2 sulfate. Here we have 6.022 times 10 to the 23rd sodium chloride formula units, and here we have a mole, or 6.022 times 10 to the 23rd copper atoms. So as you can see, atoms, molecules, and formula units must be really small if we can obtain a mole of them easily. So how would you go about obtaining a mole of something? Like a dozen, you can just count it out, or 2 dozen, or 3 dozen. But a mole is just too big. In fact, if you tried to even just count to a mole, it would take you 19 quadrillion years to count to a mole, which you clearly can't do because you don't live that long. So what I have here are pictures of a mole of a bunch of different elemental compounds. And certainly someone counted those out somehow. They didn't actually count them. How they did it is they did it by mass. So how do you count by mass? Well, you need something called a molar mass. So a molar mass is the mass of 1 mole of any substance. So if I have 6.022 times 10 to the 23rd atoms of something, or 6.022 times 10 to the 23rd molecules of something, that something has a molar mass. I could weigh that amount of something, 6.022 times 10 to the 23rd, weigh it, get a molar mass in grams per mole. Now here's the thing, you can't count out a mole, it would take too long, so how do we obtain a molar mass so that we know how much 1 mole of something weighs? Well, that's where your periodic table comes in. So let's look at something like copper. So here's copper on your periodic table. If you look underneath copper, there is an atomic mass. So if you remember, we talked about atomic mass a long time ago. So the atomic mass for copper happens to be equal to about 64 grams. So 63.546 atomic mass units. Well, that also happens to be in grams the mass of 1 mole of copper atoms. So if I want to weigh out 6.022 times 10 to the 23rd copper atoms, I would just need to get copper and put it on a scale until it weighs 63.546 grams. So we could do this for any of the elements on our periodic table. So what about iodine? What if I want a mole, or 6.022 times 10 to the 23rd iodine atoms? Well, we'd go to our periodic table and we would find iodine. So here's iodine. Its mass is 126.90 atomic mass units, which is equal to 126.90 grams per mole of iodine. So if I wanted to weigh out a mole of iodine, like right here, I would need to weigh out 126.90 grams would be a mole, or 6.022 times 10 to the 23rd iodine atoms. What if I wanted to obtain a mole of something a little more complicated, like, say, mercury 2 oxide? I want to measure out a mole of mercury 2 oxide. So the first thing I would need is its chemical formula. So the chemical formula for mercury 2 oxide is HgO, which means that if I have 1 mole of mercury 2 oxide, what I really have is 1 mole of mercury atoms and a mole of oxygen atoms. And so if I know the mass of a mole of mercury atoms and the mass of a mole of oxygen atoms, I can just add the two together, and that will give me the mass of 1 mole of mercury oxide. Where would I obtain the information of the mass of a mole of mercury and the mass of a mole of oxygen? Why, I would get that from our periodic table. All right, so mercury is here and oxygen is here. And you can see that mercury has a molar mass of 200.59 grams per mole of mercury, and oxygen has a molar mass of 15.999 grams per mole of oxygen atoms. So if I add those two together, I get a molar mass for mercury oxide of 216.589 grams per mole. And so that's what you would find in this container, is someone just weighed that out on a scale and put it in this beaker, and you have a mole of mercury 2 oxide. Let's look at something a little more complicated. What about sucrose? Sucrose is table sugar. It's made, each molecule of sucrose is made of 12 carbons, 22 hydrogens, and 11 oxygens. So if I had a mole of sucrose, what I have is 12 moles of carbon atoms plus 22 moles of hydrogen atoms plus 11 moles of oxygen atoms. So I would need to look up the molar mass for carbon, hydrogen, and oxygen, and then multiply them by these numbers. So if you look on your periodic table, you will find that a mole of carbon weighs 0.11 grams, and you have 12 moles of carbon in a mole of sucrose. 1.008 grams would be a mole of hydrogen atoms, and you have 22 moles of those. And then oxygen is 15.999 grams per mole, and you have 11 moles of that. You would end up, if you did the math on this correctly, with a molar mass for sucrose of 342.297 grams per mole. So if I wanted to weigh out a mole of sucrose, I would have to weigh out 342.297 grams of it. So even though you have a mole of each of these substances, so a mole of mercury oxide and a mole of sucrose, you get two different masses. And the reason you get two different masses, of course, is because they each weigh something totally different. So if I had a mole of basketballs versus a mole of, I don't know, kittens, they wouldn't weigh the same because they're two totally different things. I would have the same amount, 6.022 times 10 to the 23rd basketballs and 6.022 times 10 to the 23rd kittens. I would have the same number, but I would not have the same mass because they have different masses. So that brings us to the end of our presentation on what a mole is.